Bismillahirrahmanirrahim. Okay, so in the last class we studied free and forced vibration, and also we went through the definition of resonance, right? If you remember from the definition of resonance, it says that every body has its own vibration, okay, natural frequency, and there will be an applied frequency, right? When the natural frequency equals the applied frequency, natural frequency equals the applied frequency, that time we can say that the resonance will be produced. And in such case, what will happen? As the frequencies are equal, there will be maximum amplitude will be produced, right? So this type of vibration is called resonance. And we also saw a practical example, right? Tacoma Bridge. I told you to see the video again. I don't know whether you saw it or not.
Sir, Dixie.
Very good. Okay. So that is a practical example of resonance. The natural frequency of the bridge equaled the natural frequency of the yak that was around the bridge. So as a result, resonance was produced. Now we will go through an experiment that is written. So it can be said that before the experiment, the last line, okay? On page number 537, you can see that. So it can be said that resonance is a special type of forced vibration. This is very much understandable. Irfan, তোমার ওখান থেকে noise আসছে. I will mute you, okay? Acha. So resonance is a special type of forced vibration. Okay. Here you can see that there is a applied frequency, right? So whenever there is applied frequency, it is a forced vibration. But in case of forced vibration, it's a special case where the frequency is being equal to the natural frequency, right? Okay. So experiment what we are doing, a rubber cord XY is stretched horizontally from which four simple pendulum PQRS are suspended side by side. Actually, it is referring to the figure 9.8b that is on the next page. 9.8b on the next page, as you can see. So I will draw the figure on the board, okay? From here, I will suspend four pendulum. This is P, Q, R, and S. Okay. So I have suspended this four pendulum. Now what I will do? The length of P and Q are equal. As you can see, P and Q, the length of it are equal, and the length of R is a bit more than P and Q. Yes, R is a little bit longer than P and Q, right? And also S is a bit less than P and Q. Yes, S is shorter, right? Considerably shorter, and R is considerably bigger. Now, if we set the pendulum P in vibration, that means if I give this one, a little bit of displacement, what will happen? It will start vibrating now, like this. Okay, it will start vibrating like this. So this vibration will be, transferred to Q pendulum through the rubber, and also subsequently it will be transferred to the pendulum R and S, right? So what we can see is we are giving a vibration in this one, and the other is also getting influenced due to this vibration. So for this one, it will be natural frequency, and for the other one, it will be forced vibration. So sorry, this is free vibration, and the other one will be vibrating under the influence of this vibration. So for QRS, it is going to be forced vibration, right? Now, as you can see, P and Q both have the same length, right? As both have the same length, they will have the same frequency. And as R is longer and S is shorter, so as a result, what will happen? That frequency is going to be different. Now, as P and Q both have the same frequency, okay? Now, the frequency of vibration of P is equal to the frequency of the vibration of Q. Resonance will take place, right? Because in case of Q, the natural frequency is equal to the applied frequency, right? Natural frequency is equal to P, and the forced frequency is also, it is getting from P. So as a result, what will happen? Q will experience a resonance, right? Because for Q, the natural frequency will be equal to forced frequency. Now think about R and S, okay? Now R and S have different frequencies. So what will happen? Resonance will not take place, right? So if you remember forced vibration definition, we studied that, okay, a forced vibration is applied to a certain vibrating particle. What will happen? At first it will vibrate irregularly, okay, with a smaller amplitude it will vibrate irregularly, and then what will happen? It will try to vibrate with its own frequency, but it cannot, because we are applying a frequency on this one through this rubber, right? So as a result, what will happen? It will not be able to vibrate with its own frequency. It will vibrate irregularly for some time, and then gradually it will adjust to the frequency that I have applied, right? This is true for S also. Okay. So gradually, what will happen? After some time, they will start vibrating with the frequency of this P pendulum's frequency. Okay. We will go through this one. You see the experiment on 537 page. It is very clearly written. Okay. What I have explained, it is written here. We will go through the book now. Okay, so in experiment I am reading the fourth line. Now if we set the pendulum P in vibration, instantly the pendulum Q will start vibrating. See, instantly, this is the first pendulum after P, right? So it will instantly start vibrating. The pendulum R and S also start to vibrate simultaneously, but their amplitude is very small. Yes, okay. As in this case the resonance is taking place, so with maximum amplitude it will vibrate, but in this case the amplitude will not be that much greater. Why? Because the forced frequency is not equal to the free frequency, right? Okay. So as a result, what will happen? The pendulum R and S also start to vibrate simultaneously, but their amplitude is very small, and they will come to rest after a short while. Yes, they will try to vibrate with their own frequency, but they will not be able to do so. They will stop, and then again they will start to vibrate with the frequency applied by P, right? This is what will happen. Though they again start vibrating after a few moments. See, this is the last line. Okay, so they will try to vibrate with their own frequency, but they will not be able to do that. So as a result, they will stop and then start again vibrate with the frequency that has been applied on them. Now, after the experiment box, see the length, since the length of P and Q are same, their frequencies are equal. This is what I have been telling you, right? When P starts vibrating through the thread, it is transmitted to three other pendulum. Yes, when P starts vibrating through the thread, it will be transmitted to all other. So all other will start vibrating, right? Okay. Transmitted to three other pendulums and they vibrate due to forced vibration. The natural frequency P is being equal to Q. See, the natural frequency in this case and this case will be equal, right? Because the amplitude of Q becomes equal to the P. Okay, amplitude also will become equal. I'm in the next page now, 538 page. That means resonance is produced. Okay, so but the frequency of R and S not being equal to that of P, resonance will not be produced. Okay, so in case of R and S, resonance will not be produced. So at first they vibrate irregularly with a small amplitude, and at last they cease to vibrate. ওরা কি করে? থামায় দেয় ভাইব্রেশন করা, ঠিক আছে? Then the reason for restarting of vibration, আবার এরপরে vibration start আমরা বলছিলাম না? So why it will start again? The reason for restarting of vibration after being stopped is retransmission of vibration through it. Through as long as this one will continue to vibrate, it will be continued to be transmitted through the thread, right? Okay. Now resonance box. Okay, this is another example. Okay, of resonance. Sometimes tuning forks are mounted on a hollow wooden box. Now, what do you understand by hollow wooden box? Hollow wooden box mean, let us say now this is a pipe, right? As you can see, this is a pipe. So there is hole inside. Okay, it is not filled. It is not solid. It is hollow. Do you understand this one? This is hollow. Okay. So hollow is something there is air inside that. Okay. So when sometimes tuning forks are mounted on a hollow wooden box, our wooden box is drawn here. It is very hard to imagine that it is hollow. Okay, I will try to show you. This looks like a solid box, but if it is hollow, then it will look like this. Okay. You can understand now that this is hollow. Okay, this is the wooden piece. Okay, there is a hole throughout. Okay, so this, you can imagine, right? So on this hollow wooden box, we will mount a tuning fork. Okay, so the frequency of the tuning fork must be equal to the frequency of the ear. Okay, there must be some device through which we can actually measure the frequency of the ear. Correct or not? So if you know the frequency of the ear, we can take a tuning fork, the frequency of which is equal to the frequency of the air inside it. Okay, now what is the purpose of doing this? When we struck, the tuning fork, it will start vibrating. As it has started to vibrate, what will happen? It will produce wave in the air inside the box, right? It will produce a vibration in the air inside the box. So the frequency of this tuning fork is equal to the frequency of the air, right? So this tuning fork will apply a forced vibration on the air, right? The air was not vibrating on its own. Okay. Now if I vibrate the tuning fork, it will cause a starting of a vibration in the air, right? Now the applied frequency will be equal to the natural frequency of the air, correct or not? So as a result, the sound that will be produced will have higher intensity, right? Higher amplitude, we can say. So a loud sound, a sound with higher intensity will be produced. This is what they are saying here. Come to the book. Sometimes tuning forks are mounted on a hollow wooden box. The size of the box is made such that the natural frequency of the air inside the box is equal to the frequency of the tuning fork. This is what I told you, that the tuning fork frequency will be equal to the frequency of the air inside it. So when the tuning fork is made to vibrate, resonance is produced and intensity of the sound of the tuning fork increases. Yes, resonance is produced, so the intensity will increase. Since the type of box increases the intensity of sound of the tuning fork, producing resonance. Hence it is called resonance box. Yes, here we can produce resonance, that is why we can call this is a resonance box. Now there are practical examples of this resonance box, right? Can anybody tell me a practical example? Anybody? Anybody can tell me a practical example of this resonance box? We see the use of it. Everyone have seen, I'm sure, guarantee. Nobody? Rifat?
Yes, sir.
তুমি বলো না কেন? ক্লাসের মধ্যে তো সমস্ত করবা না?
Sitar.
Sitar is there. The most common one. কমনটা বলো।
হ্যাঁ?
সবচেয়ে কমনটা বলো, সবচেয়ে কমন। সিতার তো অনেক। Guitar. Okay. Guitar is an example of this resonance box. Thank you. Okay. Then, so as we are talking about guitar, okay, as you know that guitar has a hollow wooden box, right? Inside there is air and some strings are mounted on it, and we vibrate the strings with our fingers, right? With our fingertip we make the string vibrate. So as a result, what happens? The air inside the hollow wooden box also start to vibrate due to the forced vibration, right? So it is made in such a way that the frequency of the string equals the frequency of the air inside the box. So as a result, resonance is produced over there and the intensity of the sound increases. Understood? So this is a practical example of resonance box. So I will continue reading. Okay, the intensity of sound of musical instrument like violin, sitar, and guitar, etc., is increased in same way. Violin also. Okay, you see there is strings, we vibrate it and sound is produced. And sitar, in Bangladesh it is called ektara, I guess. I am not sure. Okay, so etc. is increased in same way. Here the strings are mounted on a hollow wooden box. When the vibrating starts to produce sound, the air inside the box also vibrate and resonance is produced. As a result, the intensity of the sound increases. Okay, this is what I have just explained to you. So till now, do you have any doubt? If you have any doubt, kindly raise your hand.
স্যার রেজোন্যান্স বক্সটা কেমনে কাজ করে একটু আবার বলবেন?
এই যে রেজোনেন্স বক্সটা হলো, এটার ভিতরে এয়ার আছে। ওকে, সো যেহেতু এটার ভিতরে এয়ার আছে, এয়ারের একটা ন্যাচারাল ফ্রিকোয়েন্সি আছে। তো এই ন্যাচারাল ফ্রিকোয়েন্সির ইকুয়াল ফ্রিকোয়েন্সি ওয়ালা একটা টিউনিং ফর্ক আমরা নিলাম। তো এই টিউনিং ফর্কটাকে যদি আমি এখন হিট করি, এটা ভাইব্রেট করবে। তো এটার যে ফ্রিকোয়েন্সিতে ভাইব্রেট করবে, নিচের এয়ারেরও সেম ফ্রিকোয়েন্সি না? এখন দেখো, এটা ভাইব্রেট করলে এয়ারের মধ্যে একটা ভাইব্রেশন ক্রিয়েট হবে। এখন যে ফোর্সড ভাইব্রেশন আমি এয়ারকে দিতেছি, সেই ফোর্সড ফ্রিকোয়েন্সি আর এয়ারের যে ন্যাচারাল ফ্রিকোয়েন্সি, ওটা ইকুয়াল আমি শুরুতেই বলে রাখছি। So, যেহেতু natural frequency is equal to the frequency of the applied vibration, what will happen? Resonance will take place and the intensity of the sound will increase. দেখো অনেক loud sound শোনা যাবে. There are some videos in the YouTube. Okay, I couldn't download it today. And then the next class I will show you, or else you can just write resonance box in YouTube and you can see it yourself. Okay. আমি আসলে গত কয়েকটা ক্লাসের ভিডিও থেকে দেখলাম যে ইউটিউব থেকে যদি আমি ভিডিওগুলো প্লে করি, যদিও আমার এখানে দেখাচ্ছে যে খুব স্মুথলি প্লে হচ্ছে, কিন্তু পরে রেকর্ডিং এর মধ্যে এগুলো আসলে এতটা ক্লিয়ার আসে না। ওই যে তোমাদেরকে দেখাছিলাম না স্ট্যান্ডিং ওয়েভ, স্ট্যান্ডিং ওয়েভটা আসলে অত মানে স্মুথ একটা ভিডিও না। ঠিক আছে, স্মুথ ভিডিও বলে একটা কথা আছে না, যে বোঝা যাচ্ছে কি হচ্ছে। তো আই ফেল্ট ইট ইজ নট দ্যাট মাচ স্মুথ. So that is why what I'll do, I will download the video and then I will try to show you, and then I will check whether it is smooth or not. Okay. Acha. So if you have understood till now, okay, we can move to the intensity of wave. Okay, definition: intensity is the amount of energy flowing per second per unit area perpendicular to the direction of propagation of wave. We know that here, intensity of wave, intensity is the amount of energy flowing. Obviously, we know through wave we transfer energy, right? Okay, through wave we always transfer energy. Now, let us say in t amount of time, okay, through a area we are transferring an energy which is equal to p. Okay, so in unit time, through unit area, how much energy I will be transferring? T by, so that's it. So here it will be P divided by A into T, right? Okay. So now the area, the formula of area, it will depend, on the area of the shape. Okay, here we are considering it is a sphere. In case of a sphere, what will happen? The area will be 4 pi r square, right? And if the time is already t is equal to 1 second, then what will happen? This intensity I will be equal to p by r.
স্যার স্যার আবার একটু বুঝান, আমি বুঝি নাই
কোন পার্টটা? ইন্টেন্সিটি
এতো এপি। হ্যাঁ,
আচ্ছা, আমরা বললাম কি, দেখো ইন্টেন্সিটির ডেফিনিশনে কি বলছে, the amount of energy flowing per second. Per second মানে কি? in 1 second per unit area, 1 area. ওকে, এটার মধ্যে দিয়ে যতটুকু এনার্জি ফ্লো হবে, আমরা শুরুতে ধরে নিয়েছি যে t সেকেন্ডে a এরিয়ার মধ্যে দিয়ে p পরিমাণ কি হচ্ছে, এনার্জি ফ্লো হচ্ছে। ঠিক আছে, তাহলে ইউনিট সেকেন্ডে এবং ইউনিট এরিয়া দিয়ে কতটুকু ফ্লো হবে, a আর t, এটা নিচে ডিভাইড হয়ে যাবে না? Okay, now if we consider as they have considered in the book, okay, they have considered this time to be 1 second. Okay, our area at a sphere area, this is the area of a sphere, area of a sphere. So if you consider that it is a sphere, then what will happen? The area A can be written as 4 pi r square, right? So then if I replace this value over here, then I will get T by 4 pi r square, and this is intensity. Intensity is expressed as I. Okay. Now I can deduct the unit from here, right? This is energy, so this will be joule, right? Joule, area is meter square, and time t is second. So the unit can be written as joule per meter square per second. Okay. Now if you notice, 1 joule per second. Joule per second is 1 watt. Okay, joule per second means what? Watt by time. Watt by time is power, right? This T represents power. Power is equal to watt divided by time. So what is the unit of power? Power unit is watt. Watt unit is joule, and time is second. So joule per second can be replaced by watt, right? So here we have joule, here we have per second. So joule per second can become watt, and meter square will be there. Meter inverse 2 will be there. So this unit can be written as watt per meter square. Okay. The unit is clear. Why the unit is like this? Joule per meter square per second. Okay, joule per meter square per second. Now joule per second, this part will become W, because joule watt divided by time is power, right? And the unit of power is watt, so it will be watt per meter square. Any problem?
No, sir.
So kindly go through the explanation of the book and also go through the mathematical expression for intensity. I will be back in a minute. Okay, I will come back. Okay. So now let us try to go through, the mathematical expression for intensity. Okay. Let a wave of amplitude A. What is the amplitude? Amplitude is A, and frequency is F, propagating through a medium with velocity C. C is the velocity. Along the path of propagation of this wave, of E amount of energy is flowing. Okay, now the energy flowing is E, not P anymore. Okay, we considered P a little bit ago. Okay, so now the energy flowing is E. So E amount is flowing through area A. Area is A around a point in the medium in time T. The time is T. The energy flowing perpendicularly in unit time through the unit area, that is intensity of the wave. Yeah, from here I can find the intensity of the wave, right? Energy divided by area into time. This is our intensity, right? So now length of the portion of the, okay, so I can multiply L in both numerator and denominator, right? Now here L is the length of the medium of the portion. Okay. Then if you notice area into length, it will give me volume, right? Here V is the volume. V is equal to area into length, that is volume. Okay. So
Sir, E key.
E হচ্ছে energy. energy. Okay, and L divided by T, length by time, this is velocity. E divided by V, and this is a small v. Okay, let me denote it by V prime. Okay, V prime is the velocity here. Velocity is equal to
স্যার টি কেটে ফেলেন
কি স্যার?
স্যার ভিটি হবে না, শুধু ভি হবে।
কোথায়? ও আচ্ছা, রাইট, length by time, এটা তো t চলে যাবে তাই না, L by T will become this one. So then we can write it will be E V prime divided by V. V prime is the velocity and V is the volume. Okay, do not confuse or get confused between them. In the book they have mentioned the velocity V as the small v and the volume V is the capital V. Okay, so then what we have, we know that the wave is propagated due to simple harmonic motion of the particles of the medium. Yes, whenever wave is propagating through some medium, the particles will have simple harmonic motion, right? As we already know, if the wave is propagating, then a particle here, it will go up, it will go down. So it will go through simple harmonic motion. And in case of simple harmonic motion, the total energy is equal to the maximum potential energy or maximum kinetic energy. This is very true. If you have forgotten, then I can, tell you. See, at this position, at this maximum position, it is maximum potential energy, right? Because this is the maximum height covered by the body, maximum potential energy, and the velocity is 0 here. Here, maximum potential energy, but kinetic energy is 0 because the velocity is 0, right? Okay, so the total energy, if I take the summation of the total energy, then what will happen? This will be equal to the maximum potential energy, right? Because kinetic energy is 0 here. Okay, and again, as it will come down, what will happen? The potential energy will decrease and kinetic energy will increase, and at this point it will be maximum kinetic energy, right? Maximum kinetic energy and potential energy is going to be 0. If you take the summation of the total energy, okay, if you find the total energy and take the summation of these two, you will find that this is equal to maximum kinetic energy because this is 0, and this amount, this total energy found here will be equal to the total energy here, right? Because we know that conservation law of momentum says us that energy can neither be created nor be destroyed. It will be transformed from one form to another. Okay, so maximum potential energy will be equal to the total energy, or I can say maximum kinetic energy at this position will be equal to the total energy, right? So this is what they are saying. And in case of simple harmonic motion, the total energy is equal to the maximum potential energy or maximum kinetic energy depending on the position of the object. If the object is at maximum height or at the amplitude position, then what will happen? It will be equal to maximum potential energy, or if it is in equilibrium position, then what will happen? It will be equal to maximum kinetic energy. Acha. So then I can,
স্যার এটা একটু আবার বুঝাবেন?
কোনটা? এই যে এটা বুঝো না, এই যে এই বডিটাকে যখন আমরা ধরে এখানে নিয়ে যাব, আমরা এটাকে একটা সার্টেন হাইটে তুলছি না?
হ্যাঁ।
তো তাইলে এটার মধ্যে কিছু পটেনশিয়াল এনার্জি জমা হবে। তুমি দেখো বডিটা এখানে ছিল, আমি এটাকে ধরে এখানে নিয়ে গেছি। I have applied some force and I have given it some displacement. So I have done some work and that work will be stored as potential energy in this body. এবং আমি যখন এটাকে ছেড়ে দিব, কি হবে? এই potential energy ইউজ করে ও এখন নিচের দিকে নেমে আসবে, and as it is moving it has some kinetic energy now, right? So from where that kinetic energy is coming? From the potential energy that I have stored inside the body. Correct or not? Okay,
Yes.
so at this position it is maximum potential energy because after this point the body is coming down, potential energy decreases. So this is the maximum potential energy, and at this position the velocity is 0. At maximum position velocity is 0, so kinetic energy is 0. Now if you take the summation of these two, potential energy and kinetic energy, যে অ্যামাউন্টটা তুমি পাবা সেটা ম্যাক্সিমাম পোটেনশিয়াল এনার্জির ইকুয়াল দিতে হবে, তাই না? Let us say maximum potential energy এখানে 5 for example, আর এটা তো 0, তাই না? আমি যদি 5 আর 0 দুটোকে প্লাস করি তাহলে আমি কি পাবো 5 তাহলে টোটাল এনার্জিটা এখানে ম্যাক্সিমাম পোটেনশিয়াল এনার্জির ইকুয়াল না then again if I এখন এটাকে যদি আমি ছেড়ে দিই তাহলে কি হবে এটা এখন একটা মোশনে আসবে এবং মোশনে আসলে কি হবে এটার ভেলোসিটি আছে সো এটার কাইনেটিক এনার্জি আছে এবং ম্যাক্সিমাম ভেলোসিটি কোথায় হবে এইখানে এই পয়েন্টটা ক্রস করার সাথে সাথে আবার ভেলোসিটি কমতে থাকে তাইলে এইখানে যেহেতু ম্যাক্সিমাম ভেলোসিটি এখানেই ম্যাক্সিমাম কাইনেটিক এনার্জি হবে কেন কারণ হচ্ছে কাইনেটিক এনার্জি is equal to half mv square we know this one right so that is why এখানে ম্যাক্সিমাম কাইনেটিক এনার্জি হবে এবং দেখো এই পয়েন্টের থেকে যত উপরে উঠবে তত আমাদের পটেনশিয়াল এনার্জি জমা হবে কিন্তু এই পয়েন্টে যদি ব্যাক আসে হাইট এখন 0 তাহলে পটেনশিয়াল এনার্জি কত হবে 0 সো এখানে কাইনেটিক এনার্জি যদি এখন আমার 5 হয় এবং পটেনশিয়াল এনার্জি 0 এই দুটো আমি প্লাস করলে টোটাল এনার্জি আমার কত আসে 5 which is equal to maximum kinetic energy এই কারণে আমি বলতে পারি যে মানে এই যে কোনো একটা সিম্পল হারমোনিক মোশন বা পার্টিকেলের ক্ষেত্রে the maximum energy is going to be equal to maximum potential energy or maximum kinetic energy दोनोंটা ভ্যালু কিন্তু সেমই হবে okay so this is the case still there is doubt Irfan
No, sir, I'm বুঝছি।
okay so I can erase this part so here what they are saying okay so the total energy this E okay this E is equal to what I can write it is equal to maximum kinetic energy right so maximum kinetic energy will take place when the velocity is maximum right as you saw at the equilibrium position the maximum velocity was there so when we will have the value of velocity maximum we will have the maximum kinetic energy and maximum kinetic energy is equal to the total energy which is E here right so I can write it since the simple harmonic motion is a part of circular motion and in the case Vmax equal to omega A we already studied this one Vmax is equal to omega A this applies for circular motion right and circular motion is deeply connected to simple harmonic motion right we already saw the relation in the periodic motion chapter okay so since the simple harmonic motion is a part of circular motion in this case Vmax we can replace it by omega A omega is the angular frequency we know this is the angular velocity and this is the amplitude right so if we replace the value in this equation then what will happen E will be equal to half n omega A whole square and so half n omega square A square correct or not okay so then what we will do we will plug the value of E back in this equation okay I will show you
Yeah.
from tomorrow
Tomorrow there won't be classes because a national day. So you can inform students also. Which class students are there?
grade 11
Grade 11.
I already told them
Hi students.
Hi, assalamu alaikum, teacher.
Walaikum assalam.
Teacher.
How are you?
Fine, teacher. Alhamdulillah.
well I didn't notice that the previous meeting has already ended so I hope you can replace the value okay the value of E we have plugged back here okay and then we have taken this m over volume mass by volume this will give the density rho right omega square A square B prime we know that density rho is equal to mass by volume right okay then we will replace omega by 2 pi f omega is equal to 2 pi f we already know this right so if I calculate this one I will be getting 2 pi square rho multi A square B prime A square F square. This is the final equation to find out the intensity, okay? We must know the density, we must know the velocity, we must know the amplitude and also the frequency. So if we have this, things, we know these quantities, then what will happen? We can calculate the intensity, okay? So students, today up to now, okay, I will send you both the videos through YouTube. Inshallah, we will meet on Sunday, okay? No more class today. Thank you for joining. Assalamu alaikum.